Have you ever looked up at the night sky and wondered, where does it all end? The stars scatter like diamonds across a velvet backdrop, and beyond them, galaxies, vast islands of light adrift in an endless ocean. We gaze upward, searching for an edge, for a border, for a final curtain that closes upon the stage of existence. But what if there is no end? What if space stretches on forever like a dream with no waking? Or worse, what if it does end but not in the way we imagine? Tonight, we set out on a journey to the farthest reaches of reality. A journey to test the limits of human thought, to chase the edges of the universe, and to ask a question older than civilization itself. Does space end? Stay with me. Because the closer we get to the answer, the stranger the universe becomes. Close your eyes for a moment. Picture the night sky, not as you see it from a city window, dimmed and drowned by the glow of neon lamps, but as our ancestors saw it, beneath skies so clear the heavens blazed with fire. The Milky Way, stretched like a river of frozen light, cascaded across the darkness. Every pinprick was a star, a world, a possibility. And then, imagine yourself staring long enough that a thought creeps into your mind, one so disquieting that you almost brush it away. A thought that whispers, where does it end? This question is older than civilization, older than writing, perhaps older than fire itself. It is the question of infinity. The very first humans who looked up must have wondered if the stars were candles lit by gods, or holes in the fabric of a vast dome. They did not know what planets were, or galaxies, or cosmic radiation. But they did know the feeling of standing before something too large to grasp. Infinity is not natural to the human brain. We are creatures of limits. We measure the day by the cycle of the sun, the seasons by the turning of the earth, our lives by the ticking of a heart. We crave boundaries, edges, endings. But the night sky refused to give us one. It offered only silence and the endless, unbroken canvas of stars. So our ancestors told stories. The Egyptians imagined Nut, the goddess of the sky, her body arched protectively across the world. The Mesopotamians believed in a cosmic ocean, a dome of heaven holding back primordial waters. The Chinese pictured the heavens as a great canopy, supported by pillars, each aligned with sacred mountains. Every culture, in its own way, tried to draw a line around infinity, to make it smaller, safer, containable, to turn an endless void into a ceiling painted with gods. For millennia, the question of infinity wasn't just above, it was all around. Travelers asked, if we walk far enough, do we reach the edge of the earth? Sailors feared that if they pushed too far, their ships might topple into nothingness. The Babylonians drew maps of the earth as a flat disk, surrounded by an ocean, beyond which lay darkness. The Greeks wrote of Oceanus, the river that circled the world, and of lands beyond it, half imagined, half feared. This craving for borders wasn't foolish. It was practical. A farmer needed to know the edge of his field. A king the border of his kingdom. Why shouldn't the universe also have a wall, a final horizon? But here is the strange part. Every time humanity found an edge, it vanished. The earth wasn't flat. The oceans weren't endless chaos. The heavens weren't a dome. Each boundary dissolved into a larger one, like Russian nesting dolls, each containing a bigger mystery. Infinity always retreated, but it never disappeared. To the ancient mind, infinity was not awe, it was terror. It meant the absence of order, of boundaries, of control. Aristotle himself rejected infinity. To him, the universe was finite, perfect, and bounded by crystalline spheres that held the stars in place. Zeno of Elea, with his paradoxes, showed just how slippery infinity could be. If you walk halfway to a wall, then halfway again and again, you will never arrive. Infinity breaks reason. It bends the mind until it snaps. Infinity was a door philosophers were afraid to open. For to admit it was to admit human smallness. If the universe has no end, then we are not its center. We are not even close. We are not anywhere. But still a few dared. In the 1st century BCE, the Roman poet Lucretius offered a simple but devastating image. Stand at the edge of the universe, he wrote. Now throw a spear. If the spear flies forward, then the universe extends beyond. If it strikes a wall, then what lies beyond that wall? The spear pierces everything. It smashes through every boundary, and with it, infinity comes crashing in. Lucretius' question was not answered for 2,000 years. And perhaps it still isn't. In the late 1500s, a man named Giordano Bruno stood beneath the Italian sky and dared to imagine more. He looked at the stars and declared, "Each is a sun, each sun may have worlds, and the universe has no edge, no center, no walls." For Bruno, infinity was not terror. It was liberation. It meant a cosmos overflowing with life, worlds upon worlds without end. But the world was not ready. His ideas threatened the delicate order of church and state. And so, in 1600, Bruno was led to a public square in Rome, chained to a stake and burned alive. Infinity, it seemed, was not just a philosophical danger. It was a political one. Centuries passed. Telescopes were built. Galileo turned his glass skyward and saw moons circling Jupiter, mountains on our own moon, the Milky Way resolved into countless stars. The universe, once thought small, revealed itself to be enormous. Every discovery stretched the question further. How far do the stars go? Beyond them, what lies? Are galaxies the final units of existence, or are they part of something greater still? By the 20th century, Edwin Hubble discovered that galaxies are not fixed but racing apart, that space itself is expanding. And with expansion comes the inevitable question. If it is growing, then what is it growing into? Infinity again stood at the door. Imagine lying awake at night, staring at the ceiling, only to realize the ceiling is not a ceiling but a window into endlessness. That was the position of the modern mind. For the first time in history, infinity was not just a myth or a dream. It was a real possibility. And real infinity is not kind. Think of it this way: if the universe is infinite, then there are infinite versions of you. Infinite Earths. Infinite tragedies, infinite joys, infinite everythings. Somewhere, another you is listening to this same story. Somewhere, another you never existed. The human brain struggles against this. It seeks to escape, to draw a border, to build a wall. But infinity laughs. And so, here we are, in the present day, with satellites orbiting Earth and telescopes peering to the edge of time itself. We have mapped the observable universe, a bubble nearly 93 billion light-years across. But we call it observable because beyond it, we cannot see. Does that bubble mark the end? Or is it merely a horizon behind which space continues forever? Scientists debate. Some argue the universe is infinite, stretching without end. Others suggest it is finite but unbounded, like the surface of a sphere. You could travel forever without encountering a wall, yet it is not endless. Still others whisper of multiverses, of countless universes bubbling in an eternal foam. In that vision, our universe is not the whole, but just a drop in an infinite sea. And the question returns, sharper than ever: does space end? As you drift, listening, let the weight of it sink in. Imagine walking to the edge of the observable universe 46 billion light-years away, only to find that beyond it lies more. And beyond that, more still. There is no arrival, no final door. Only distance, only silence, only the endless. This is the nightmare and the beauty of infinity. It strips us of importance but also grants us wonder. It reminds us that we are small, but also that we are part of something so vast it defies comprehension. The question of infinity is not just a scientific puzzle. It is a mirror. When we ask whether space ends, we are really asking, does anything? Do we? Does time? Does existence itself? The truth is, we do not know. Perhaps we never will. Perhaps infinity is not meant to be solved, only lived with. But the question remains, whispering through history, carried from fireside myths to modern telescopes, from the minds of philosophers to the hearts of dreamers. Does space end? Or does it stretch on forever, a story with no final page? And so our journey begins. We are going to step into the myths of the ancients, not because they had the right answers, but because they dared to ask the right questions. Their stories are not just tales of gods and monsters, but the first trembling attempts to draw a map of infinity. And in those myths, we may find the first footprints of the endless. Imagine a world before maps, before satellites, before even the concept of a globe. Imagine walking across a plain until the horizon swallows you, the sky a dome above your head, and the land stretching only as far as your feet can carry you. Beyond the horizon lies the unknown. And in that unknown there must be an edge. For our ancestors this was not just imagination. It was certainty. The earth, the heavens, existence itself, surely they had borders. Surely the universe had walls. This is the story of those edges. Every culture in its own way drew the sky as a shelter. In Mesopotamia, the earliest known maps of the cosmos show the earth as a flat disk surrounded by a ring of water. Beyond the water lay darkness and chaos. Above, the heavens were a great dome made of metal holding back the waters of the sky. Stars were not distant suns but holes punched through the dome, letting divine light seep through. The Babylonians believed that this vault of heaven rested upon mountains at the farthest edges of the world. If you could travel far enough, you might reach the cosmic pillars themselves. In Egypt, the goddess Nut stretched across the heavens, her star-covered body arched protectively above the world. Beneath her lay Geb, the earth god, while Shu, the god of air, held them apart. Here too the sky had shape, and that shape had limits. The gods themselves embodied the borders of existence. The ancient Chinese imagined a similar canopy. The heavens were a dome, and the earth a flat square beneath it. The edges of the earth were held by 4 great mountains, each guarded by divine beings. The sky's movements, the stars wheeling in their patterns, were thought to be the turning of this cosmic cover. These early visions weren't primitive guesses. They were attempts to impose order on the chaos. For the human mind, a universe without edges was not just inconceivable, it was unbearable. To early sailors, the horizon was more than a line. It was a barrier. When they looked out at the sea, they saw the edge of the world. To go too far was to risk falling into the void. Myths of sea monsters, leviathans, serpents, dragons, were not just stories of danger. They were guardians of the edge. The monsters lived at the borders of maps, where certainty faded into nothingness. Here be dragons, the old cartographers wrote. Not just to mark danger but to signal the unknown. In Norse myth, the Midgard serpent encircled the world, its body forming a living boundary. To cross it was to leave the realm of men and enter the void. Edges were everywhere. Mountains touched the sky. Oceans fell into nothing. Forests ended in shadow. To the ancient imagination, the universe was a series of nested walls, each hiding something larger, something stranger, something just out of reach. The Greeks were among the first to give the edges mathematical form. To them, the earth was not flat but a sphere, an astonishing leap of imagination. Yet even in this vision, boundaries remained. Aristotle pictured the universe as a set of concentric spheres. The earth rested at the center. Around it, the moon circled, then the sun, then the planets, each attached to its own crystalline shell. Beyond all these, the fixed stars were set into the outermost sphere, the firmament. And beyond that, the prime mover, the unmoved, the eternal. This cosmic machinery was perfect, eternal, and finite. It gave the heavens order and the earth meaning. But it also placed a wall at the edge of existence. You could not travel past the stars because the stars themselves were nailed to the final sphere. Pythagoras, Plato, Aristotle, they all sought comfort in finitude. To them, infinity was chaos. A universe without edges would mean no order, no harmony, no mathematics. And so the spheres stood, shining, eternal. Every culture painted the edge in its own colors. In Hindu cosmology, the universe was a cosmic ocean, endless and cyclical, where creation rose and fell in vast cycles of time. Yet even here, edges appeared. Mount Meru, the cosmic mountain, stood at the center of existence, surrounded by oceans and continents, each bordered by walls of iron. Beyond those walls lay other universes stacked like jewels. In Mayan myth, the heavens were 13 layers stacked above the earth, while the underworld descended in 9. The universe was a layered house with ceilings and floors. The edges were real, tangible, navigable. The Hebrew Bible describes a firmament separating the waters above from the waters below. The stars were fixed in this firmament, like lamps set in a ceiling. Heaven was not infinite, but a kingdom with gates, walls, and thrones. Edges define not just space but morality, order, and the divine. To cross the edge was to leave the sacred and enter the forbidden. Not all thinkers were content with walls. Democritus, the Greek atomist, imagined an infinite universe filled with countless worlds. To him, atoms swirled forever in the void, forming and dissolving endlessly. There was no final sphere, no cosmic boundary, just endlessness. But such thoughts were rare, dangerous even. Infinity unsettled the Greek mind. It could not be measured. It could not be ordered. And so it remained at the margins, whispered by a few, while the great weight of philosophy leaned on finitude. The tension was always the same. Edges gave comfort, infinity gave truth. Which would prevail? For the ancients, space was not the only thing with edges. Time itself was bounded. The universe had a beginning, decreed by gods, and an end, whether in fire, flood, or rebirth. The Norse spoke of Ragnarok, the twilight of the gods, when the serpent would rise and the world would burn. The Hindus told of kalpas, vast cycles of creation and destruction. The Mayans carved calendars that measured worlds ending and beginning again. If the universe had edges in space, it also had edges in time. To live was to move toward that boundary. To die was to cross it. And so, space and time were bound by limits, walls, endings. Infinity was too vast to fit into these early cosmologies. Only with myth could they approach it, and myth always curved back into order. Why did edges matter so much? Because edges meant protection. To know the walls of the universe was to know your place within it. A farmer could plant with confidence. A priest could pray with authority, a king could rule with certainty. Edges were psychological. They gave humans something the infinite could not: control. Infinity, by contrast, was madness. If the sky stretched forever, then what was man? A speck, a shadow, a whisper. No god could govern infinity. No king could rule it. No mind could contain it. And so, edges survived. But even as ancient civilizations drew their walls, cracks appeared. Eratosthenes measured the Earth's circumference, showing it was not flat but curved. Ptolemy mapped the heavens, revealing motions too complex for perfect spheres. Sailors traveled farther than ever before, finding no edge to the oceans. Every discovery pushed the edges outward. Every map had to be redrawn. The walls of the universe were sturdy, but they were shrinking, bending, dissolving. And in those cracks, infinity waited. Even in the ancient world, the whisper of infinity never vanished. It lived in Lucretius' spear, in Democritus' atoms, in the Hindu cycles, in the Mayan layers, in the Norse sea serpent. The edges were stories, but behind them something else stirred. Something vaster, stranger, more terrifying, the possibility that there were no edges at all. That space stretched forever. That time had no beginning. That existence itself was a sea without shore. The ancients could not prove it, but some of them felt it, and they left us their whispers, their myths, their fears. As you lie here now, listening in the quiet, imagine what it must have been like to live beneath those early skies, to believe the stars were lanterns hung on a dome, to fear the horizon as a wall, to place dragons and gods at the boundaries of the world. Imagine the comfort of knowing the universe had edges, and then, imagine the terror of realizing it might not. That is the moment we stand on now, the moment the ancients could not quite reach. For in the next age the walls would fall, the telescopes would turn, the maps would expand, and infinity would step out of myth and into science. But for now, let us linger with the ancients at the edge of their edges, in the safety of their walls. Because beyond them lies something that will change everything. In the next chapter we step into the revolution of thought, the Copernican breakthrough. A moment when the universe grew larger than anyone had dared imagine, and the walls of the cosmos began to collapse. Picture Europe in the late Middle Ages. The world is still small, closed, bounded. The heavens are spheres. The earth is the center. The stars are fixed lamps in the firmament, eternal and unchanging. Every cathedral points upward toward a finite heaven. Every scholar writes within the frame of Aristotle and Ptolemy. The universe has walls, and beyond those walls lies only God. But in the 16th century, a quiet revolution began. It did not come with fire or thunder. It came with ink and parchment, with diagrams sketched in candlelight, with a single daring idea. What if the earth is not the center of the universe? This was the Copernican breakthrough, and it cracked open the walls of the cosmos forever. For centuries the Ptolemaic system reigned. Earth sat unmoving at the center of creation. The sun, moon, and planets circled it in perfect spheres. When the planets moved strangely, looping backward in retrograde, astronomers patched the model with epicycles, small circles upon circles. The system was complicated, but it worked. And more importantly, it preserved the comfort of a universe with edges, order, and purpose. The heavens were not infinite, they were a clock, a divine machine. Everything had a place. Everything had a reason. But not everyone was satisfied. Beneath the neat geometry lurked questions. Why should Earth alone be unmoving? Why should the heavens be so messy with circles upon circles? Why should the stars be eternal, if change was possible on Earth? Something didn't fit. In 1543, a Polish astronomer named Nicholas Copernicus published a book. Its title was modest, On the Revolutions of the Heavenly Spheres. But its idea was anything but modest. Copernicus suggested that the Earth itself was in motion, spinning on its axis, circling the sun. The sun, not the Earth, was the center. To the modern ear it sounds almost obvious. But in the 16th century it was radical. It was heretical. It was a whisper of infinity. Because if Earth was not the center, then what was? And if the stars were not nailed to a sphere but hung in space, then how far away were they? Could they be infinite? The Copernican model was elegant. It explained retrograde motion naturally. The planets only appeared to move backward because Earth itself was moving. It required fewer epicycles, fewer patches. It was simpler. But it was terrifying. If Earth moved, then the heavens were not fixed. If Earth moved, then the stars must be unimaginably distant, or else we would see them shift as we orbited the sun. And if the stars were that far away, perhaps there was no final sphere at all. Copernicus never fully embraced the infinite. He still believed the universe was finite, still held on to spheres in some form. But his model cracked the first wall. And once a wall cracks, it does not stop. 60 years later, in Italy, a man named Galileo Galilei turned a telescope toward the sky. It was a simple tube of glass and wood, but through it he saw worlds. He saw the moon, not smooth and perfect, but scarred with mountains and craters. He saw Jupiter, orbited by 4 moons, little worlds circling another world. He saw Venus change its phases, proving it circled the sun, not Earth. And he saw the Milky Way dissolve into countless stars. Not a painted band of light, but an ocean of suns. The spheres were breaking. The heavens were not small, not perfect, not bounded. They were vast. They were full of worlds. And if the stars were countless, then space itself might be endless. Meanwhile, in Germany, Johannes Kepler struggled with the orbits of Mars. The circles of Copernicus didn't fit the data. Kepler tried and failed, again and again, until finally he abandoned circles altogether. The planets moved in ellipses, not circles. They sped up as they approached the sun and slowed down as they retreated. The universe was not a perfect clockwork of divine geometry. It was something stranger, more natural, more real. Kepler spoke of the music of the spheres, but his music was not confined to walls. It hinted at laws that stretched across all space, unbounded. And then there was Giordano Bruno. While Copernicus hesitated, while Galileo measured, Bruno dreamed. He declared that the universe had no center, no edge. The stars were suns, each with their own worlds. Infinity stretched in all directions. Creation itself was endless. For this he was silenced, imprisoned, burned. His ideas were too dangerous, too boundless, too infinite for the world of his time. But his vision lingered. And in time science caught up to his dream. The final blow to the ancient walls came in the 17th century with Isaac Newton. Newton looked at an apple falling and at the moon circling Earth, and he saw the same force at work: gravity. A universal law binding apples and moons, Earth and sun, stars and galaxies. Gravity was infinite. It reached across all space. There were no walls it could not cross, no boundaries it obeyed. The heavens and the earth were not separate realms, they were one. The cosmos was not a closed box. It was a boundless arena. By the 18th century, philosophers began to embrace infinity. Immanuel Kant suggested that the Milky Way was just one galaxy among many, and that space itself might be infinite. Astronomers like William Herschel mapped the stars, discovering clusters, nebulae, structures stretching farther and farther. The universe kept growing, receding, unfolding. And always the question loomed, if there are no walls, no spheres, no fixed edges, does space end at all? For medieval man, the fear was hell beyond the stars, chaos at the edge of the map, dragons at the world's rim. For the modern man, the fear was different. It was the abyss of infinity itself. A universe with no end, no center, no purpose. A universe that cared nothing for us. The Copernican breakthrough was not just scientific. It was existential. It removed Earth from the center, but it also removed humanity from the story. We were not the heart of creation. We were a detail, a whisper, a speck. And the universe stretched on, indifferent, endless. And yet, this fear carried wonder with it. For if the universe was infinite, then so were the possibilities. Other worlds, other suns, other lives. The walls were gone. The edges dissolved. And what remained was mystery. Copernicus did not give us infinity, but he opened the door. He cracked the first wall, and through it poured a flood of questions that still haunt us. How far does the universe go? What lies beyond the stars? Does space itself ever end? The Copernican breakthrough was not the answer. It was the beginning. Imagine standing on a hill at night, centuries ago, staring upward with nothing but your naked eyes. The sky looks eternal, unchanging, a dome of stars fixed like jewels in velvet. For all of human history, this was the universe, what the eye could see. Then, in the early 1600s, everything changed. A man lifted a tube of glass to the sky, peered through polished lenses, and the heavens cracked open. What looked simple became complex. What looked perfect became scarred. What looked eternal became countless. The telescope was not just an instrument. It was a doorway. And through it, the universe revealed itself, not as a ceiling but as a boundless wilderness. Galileo Galilei did not invent the telescope, but he was the first to turn it toward the sky with purpose. What he saw shocked him, and it shocked the world. The moon, long thought to be a flawless celestial sphere, was revealed as rugged and broken. Mountains cast shadows. Craters pitted its surface. The heavens were not perfect after all. Then he looked at Jupiter. There, circling the planet, were 4 moons, tiny worlds in motion. Until that night, all things were thought to circle Earth. Now, suddenly here was proof, not everything did. And when Galileo turned his telescope to the Milky Way, the band of milky light dissolved into stars. Not a painted streak. Not a divine river. But a host of suns too many to count. Each discovery shattered a wall. Each revelation pushed the edge outward. As telescopes improved, so did our vision. By the late 17th century, astronomers were seeing Saturn's rings, sunspots crawling across the sun's face, the phases of Venus. The planets were no longer wandering lights. They were worlds. And the stars? They multiplied beyond imagination. The more we looked, the more appeared. What once seemed a few thousand points of light became millions. The universe was not a neat little dome. It was a field without boundary. In the 18th century, William Herschel and his sister Caroline built telescopes larger than any before. With them, they mapped the heavens. They discovered Uranus, the first new planet in modern history. They cataloged nebulae, fuzzy patches of light that no one could explain. They counted stars, measured clusters, tried to chart the Milky Way itself. William believed the Milky Way was a vast disk of stars, and that the sun lay somewhere within it. Caroline discovered comets, icy wanderers roaming the deep sky. Together they made the universe larger, richer, stranger. And still the question grew, were those nebulae clouds of gas inside the Milky Way? Or were they island universes, galaxies each containing countless stars of their own? If so, then the universe was not just large. It was vast beyond comprehension. The telescope did something else, something no one expected. It turned into a time machine. Light takes time to travel. When you look at the moon, you see it as it was a second ago. When you look at the sun, you see it as it was 8 minutes ago. When you look at the stars, you see them as they were years, centuries, millennia ago. The farther you look, the further back in time you travel. Through telescopes, astronomers were not just seeing distance. They were seeing history. They were looking into the past, peeling back layers of cosmic time. The edges of the universe were no longer spatial. They were temporal. By the 19th century, astronomers had catalogued thousands of nebulae. Some looked like spirals, some like ellipses, some like glowing clouds. No one knew what they were. Some argued they were nearby clouds of gas. Others insisted they were galaxies far beyond the Milky Way. The debate raged for decades, and with it the question deepened. How big is the universe? Where does it end? In 1923, a young astronomer named Edwin Hubble, working with the Mount Wilson Observatory's giant telescope, pointed his glass at the Andromeda Nebula. Inside it, he identified a special kind of star, a Cepheid variable, one whose brightness reveals its distance. The result was staggering. Andromeda was not inside the Milky Way. It was far, far beyond. It was a galaxy of its own, containing billions of stars. And it was not alone. Suddenly, the universe was filled with galaxies, each an island of suns, each drifting through an endless ocean of space. The walls fell away completely. But Hubble didn't stop there. He measured galaxies and found that nearly all of them were moving away from us. The farther they were, the faster they fled. The universe was not static. It was expanding. And if it was expanding, then perhaps it had begun. And if it had begun, what would become of it? Would it keep expanding forever into infinity? Or would it collapse back upon itself? For the first time, the question of infinity was not just philosophical. It was physical. Could be measured, tested, debated. Every telescope built since has only deepened the mystery. With each advance, the edge of the observable universe retreated farther. With each discovery, infinity grew larger. Hubble's observations showed us galaxies beyond galaxies. Later, radio telescopes revealed invisible waves of light. Space telescopes freed us from Earth's atmosphere, letting us peer deeper still. And always the question remained, are we seeing the whole or only a part? Does space itself ever end? In 1995, astronomers pointed the Hubble Space Telescope at a tiny patch of sky, no larger than a grain of sand held at arm's length. For 10 days the telescope stared into that darkness. What it revealed was astonishing. Thousands of galaxies filled the image, each with billions of stars, each so far away their light had taken billions of years to reach us. That single grain of sky was not empty. It was overflowing. Multiply it across the whole sky, and the number of galaxies soared into the trillions. The universe was bigger than anyone had dared to dream. Now, in our own time, the James Webb Space Telescope peers even deeper. It sees the faint light of galaxies born near the dawn of time, their glow stretched red by billions of years of expansion. Through its mirrors, we glimpse the universe as it was just a few 100 million years after the Big Bang. The edge of the observable universe approaches. But beyond it, we do not know. Perhaps the cosmos continues forever. Perhaps it bends back on itself. Perhaps beyond our horizon lie other regions, unreachable, unknowable. The telescope has given us vision but not final answers. The story of telescopes is the story of horizons retreating. Every lens, every mirror, every observation pushes the edge farther. What once seemed a ceiling became a galaxy. What once seemed a galaxy became a universe of galaxies. What once seemed an end became a beginning. And still we ask, does space end? The telescope cannot yet tell us. It can only remind us that every time we thought we had found the edge, there was more beyond. We step into the concept of the observable universe. We will explore what we can see, what we cannot, and why there is a horizon at all. For in the depths of relativity and light's finite speed lies a truth more subtle than walls or domes. A universe with edges we cannot cross, not because they exist in space but because they exist in time. Close your eyes and imagine yourself standing in a dark meadow. Above you the sky stretches like a dome, glittering with stars. You feel as if you could walk to the horizon and touch the edge of it. But of course you cannot. The sky is not a ceiling. It is depth without measure. And yet, there is an edge to what you can see. Not because space itself ends, but because light takes time to travel. Every glance at the sky is a journey backward. Every twinkle is a memory. This idea, that our vision has a cosmic horizon, is one of the most haunting truths of modern science. It is the concept of the observable universe. Light moves fast. In fact, it is the fastest thing in the universe. Nothing outruns it. But it is not infinite in speed. Light travels at about 300,000 kilometers per second. That is fast enough to circle Earth 7 times in a single heartbeat. And yet, across cosmic distances, even that speed is too slow. When you look at the sun, you see it as it was 8 minutes ago. When you look at Sirius, the brightest star in our sky, you see it as it was 9 years ago. When you gaze at the Andromeda galaxy, you see it as it was 2.5 million years ago. Every look at the heavens is not just a look across space. It is a look through time. Now imagine carrying this thought to its limit. The universe, as far as we know, is about 13.8 billion years old. That means light has only had 13.8 billion years to travel. Beyond that, we cannot see. Not because there is nothing there, but because its light has not reached us yet. This limit is called the cosmic horizon. It is the edge of the observable universe, the farthest distance from which light has had time to arrive. And it is vast. In every direction, the horizon lies about 46 billion light-years away. Beyond that horizon, there may be more galaxies, more stars, more worlds, but they are invisible to us. They are beyond our cosmic sight. You may wonder, if the universe is 13.8 billion years old, shouldn't the horizon be 13.8 billion light-years? But space itself has been expanding. The galaxies we see now at the edge of vision were once much closer. Their light began its journey billions of years ago, but as it traveled, space stretched. The photons carried on while their source drifted farther away. So the actual distance to those galaxies today is about 46 billion light-years. That is the strange geometry of an expanding universe. Horizons that grow even as light struggles to catch up. Here is the crucial truth. The observable universe is not the whole universe. It is only the part we can see. It is like standing on a ship in the middle of an ocean. Your horizon curves around you, blue and endless. You might imagine that the ocean ends there. But you know it does not. It continues far beyond sight. The universe is the same. Beyond the 46 billion light-year horizon, there may be more of everything. More galaxies, more clusters, perhaps even infinite repetitions. We cannot know. Not yet. There is, however, a special kind of horizon, a wall of light that marks the farthest we can ever see. It is called the cosmic microwave background, or CMB. 13.8 billion years ago, the universe was hot, dense, and opaque. Light could not travel freely. It was trapped, bouncing from particle to particle. Then, about 380,000 years after the Big Bang, the universe cooled enough for atoms to form. The fog lifted. Photons were released, free to stream across space. Those photons are still arriving today, stretched into microwaves by billions of years of expansion. They form a faint glow across the sky, the afterglow of creation itself. The CMB is the farthest light we will ever see. Beyond it lies the unlit universe before transparency. Beyond it lies mystery. The observable universe is a time machine. When we look outward, we move backward through epochs. First, we see nearby stars, living and dying in familiar galaxies. Farther, we see galaxies younger, bluer, more chaotic. Farther still, we see the first clusters forming, the cosmic web weaving its threads. And at last, we reach the faint glow of the CMB, the universe as an infant wrapped in fire. We cannot look beyond this point with light. The curtain is closed. But perhaps, with other messengers, gravitational waves, neutrinos, we might glimpse even earlier times. Perhaps we might one day peer into the darkness before the first light. The concept of the observable universe is humbling. It reminds us that our sight is limited not by our telescopes, but by the laws of physics themselves. No matter how large a telescope we build, we cannot see past the cosmic horizon. The light is simply not here yet. And yet, the mind strains against this limit. What lies beyond? More galaxies? Infinite repetition? Perhaps something stranger? Curved space, multiverses, other dimensions? We cannot know. But the horizon itself whispers that there is more. Always more. Another haunting thought. No matter where you stand in the universe, you will see a cosmic horizon around you. To every observer, the universe appears centered on their location. But there is no true center. The expansion of space occurs everywhere. The horizon belongs not to us, but to the geometry of the cosmos itself. It is a reminder of Copernicus's lesson: we are not privileged. We are not the axis of creation. We are simply another point in an ocean without shore. The future of the observable universe carries its own melancholy. As space expands, galaxies drift farther apart. One by one, distant galaxies will slip beyond our horizon. Their light will never reach us again. Billions of years from now, the night sky will empty. The great clusters will fade from view. Astronomers of that far future may see only the stars of the Milky Way, blind to the truth that we now glimpse. Our age is special. We live at a time when the universe is vast and visible, when the cosmic horizon glows bright with galaxies. We are witnesses to a grandeur that will one day vanish from sight. So does space end? The observable universe says no, or at least not yet. The horizon is not a wall, not a boundary, not a final curtain. It is a limit of vision, not of existence. Beyond it may lie infinite galaxies. Beyond it may lie endless repetitions of worlds. Beyond it may lie nothing we can imagine. We stand at the shore of what we can see, staring into the mist. The sea continues, but how far? We do not know. We will venture beyond the horizon, not with sight, but with thought. We will explore theories of infinity, of curved space, of cosmic topology. For while the observable universe has edges, the universe itself may not. And that, dear listener, is where the mystery deepens. Picture yourself floating in space, no ground beneath your feet, no ceiling above your head. Around you, stars scatter across the black like embers from a fire. Now ask yourself, if you could fly forever, straight ahead, would you ever stop? Would you ever find a wall? Or would you fly on endlessly into an infinite night? This question, the shape and size of space, is one of the oldest and most haunting in human thought. Is the universe infinite, stretching forever? Or is it finite, with an edge, or perhaps curving back upon itself? Tonight, we will explore these possibilities. We will walk the strange geometries of space, from flat infinity to cosmic loops, from endless repetition to hidden dimensions. Infinity is a word that both fascinates and frightens. To the human mind, it is almost unbearable. A room without walls. A journey without end. A number larger than counting itself. For centuries, philosophers wrestled with it. Aristotle argued that the universe was finite, because infinity seemed absurd. Medieval thinkers often agreed. The heavens must end somewhere, perhaps in a sphere of stars or the embrace of God. And yet, there were always voices whispering otherwise. What if the stars stretched forever? What if creation had no edge? Infinity seduces with its grandeur, but unsettles with its emptiness. For what is man in a universe without boundaries? A speck in an endless sea. One possibility is that space is flat. That is, it has no curvature, no edge, no looping. In flat space, you can travel in a straight line forever and never return to where you began. Galaxies stretch outward without end. The horizon you see is not the universe's end, but merely the limit of light. This is the vision of infinity most people imagine. A cosmic plane expanding endlessly. No wall, no boundary. Just more galaxies, more stars, more worlds, forever. It is vast, majestic, terrifying. But there is another possibility, stranger still. Imagine the surface of the Earth. To someone walking on it, it feels endless. You can walk in a straight line forever and you will never encounter a wall. And yet the Earth is finite. Its surface is curved. What if space is the same? In a closed universe, space might curve back on itself. If you traveled far enough in one direction, you might return to your starting point as a ship does on Earth's oceans. Such a universe is finite, but it has no edge. There is no wall to hit, no barrier to cross. It is both bounded and unbounded. This is the paradox of curved space, an infinity of journey within a finite cosmos. Now imagine a third option, open, curved space, shaped like a saddle. In such a universe, lines that begin parallel diverge forever. The cosmos expands endlessly, but with a geometry that defies our intuition. Distances stretch faster than light can cross. Galaxies retreat into unreachable voids. This universe, too, has no walls. But its infinity is stranger than a simple plane. It is an infinity that accelerates, a geometry that resists closure. So which is our universe? Flat? Closed? Hyperbolic? The truth is, we do not know for certain. The evidence suggests that on the largest scales, the universe is nearly flat, so flat that if it curves at all, its radius of curvature is larger than the part we can observe. But we cannot see the whole. The cosmic horizon hides the truth. Perhaps space curves back gently, like the skin of a colossal sphere. Perhaps it saddles outward, expanding forever. Or perhaps it is truly flat, infinite without end. We cannot yet decide. The cosmos keeps its shape hidden. But the mystery deepens still further. For some cosmologists whisper that our universe may not be all. In the mathematics of inflation, the rapid expansion after the Big Bang, there is room for other bubbles of space, other universes, branching, budding, infinite in number. In such a multiverse, infinity takes on another meaning. Not only might space stretch forever here, but there might be countless other spaces, each with its own laws, its own galaxies, its own physics. Some may look like ours. Some may not. Some may sparkle with stars. Others may be dark and silent. In infinity, every possibility might exist. Even you, repeated endlessly, in endless variations, across endless skies. There is one more strangeness to consider, topology. What if the universe is not only curved, but twisted? What if it is shaped like a torus, a donut, looping back on itself? Or like a higher dimensional knot, where straight paths bend invisibly? In such a universe, you could look across the sky and see yourself. Light could circle the cosmos and return, creating ghost images of galaxies, echoes of structures, duplicates of stars. Our universe might be finite, looping, twisted in ways our senses cannot detect. The shape of space could be simple. Or it could be a labyrinth. Infinity carries one final, haunting implication. If space truly stretches forever, then every possible arrangement of matter must occur. Somewhere, unimaginably far away, there is another Earth. Another you. Another night, exactly like this one. Not once, but infinitely many times. This is the eerie logic of infinity. In an endless cosmos, everything happens, not once, but endlessly. The stars above you are not only suns. They are mirrors of possibility. They are whispers of infinite repetition. And here we return to the heart of the question. What does it mean to live in an infinite universe? In a finite cosmos, we are small, but the whole has limits. We can imagine the totality. We can picture its size, its story. But in an infinite cosmos, there is no whole. There is no total. There is no end. We are not a speck in a vast ocean. We are a speck in an ocean without shore. And the meaning of such a place is not clear. Some find it terrifying. Some find it freeing. Some find it divine. Perhaps the strangest thing about infinity is its silence. We look into the sky, and we see billions of galaxies. But if space is infinite, then those billions are nothing. They are only the faintest beginning. The telescope shows us more and more, but always, beyond it, there is more again. The silence of infinity is that it never answers. It only repeats, Father, Father, Father. Science continues to measure, to refine, to test. Cosmic microwave background studies suggest near flatness. Galaxy surveys map vast webs. Supercomputers simulate geometries. But the truth remains hidden. We do not yet know the shape of space. We may never know. We stand at the edge of knowledge, staring at the horizon, wondering what lies beyond. And so, the universe may be infinite. Or it may be finite yet edgeless. Or it may be stranger still, twisted into shapes we cannot imagine. We will follow another thread of mystery, the fate of the universe. For if space stretches endlessly, what will become of it? Will it expand forever, into cold infinity? Or will it collapse, reborn in fire? The story of space does not end with its shape. It continues with its destiny. The stars above us feel eternal. They rise and set with ancient rhythm. The galaxies whirl in their slow, majestic dance. To the human heart, the universe seems everlasting. But it is not. The cosmos is a story, and every story has an arc. A beginning, a middle, and an end. What will that end be? Will the universe collapse back into fire? Will it stretch forever into cold darkness? Or will something stranger occur, beyond the grasp of our imagination? Let us wander into the far future, into the possible destinies of all that is. We begin with what we know. In 1929, Edwin Hubble discovered that galaxies are moving away from us. The universe is expanding. Space itself stretches, carrying galaxies like leaves on a river. For decades, astronomers thought this expansion might slow. Gravity, the great puller, should tug on the galaxies, pulling them back together. Perhaps the expansion would halt, and the universe would collapse in a big crunch. But in 1998, something unexpected was found. The expansion was not slowing. It was speeding up. Something unseen, something mysterious, was pushing the universe outward. Scientists called it dark energy. And with that discovery, the future grew uncertain and strange. If dark energy continues to push outward, the universe will expand forever. Galaxies will drift farther and farther apart. The night sky will grow emptier as distant stars slip beyond our horizon. Stars will exhaust their fuel and die. New stars will form more rarely. One by one, the galaxies will fade into darkness. Trillions of years from now, the universe will be a quiet place. The great stellar furnaces will burn out, leaving only white dwarfs, neutron stars, and black holes. Even black holes will not last. Over unimaginable timescales, they will evaporate into faint radiation. At last, the universe will cool into a thin mist of particles, stretched across an endless void. A silence so deep that no spark of light remains. This is the big freeze, also called heat death. Not fire, but fading and eternal night. Yet the future is not written. If dark energy changes its nature, if its strength fades, gravity might yet reclaim its throne. In that case, the expansion would slow, then reverse. Galaxies would begin to fall inward. Clusters would collapse. Stars would collide. The universe would grow hotter, denser, brighter, until finally, all of space would contract into a single point of unimaginable fire. A mirror of the beginning, the big crunch. And perhaps, just perhaps, from that collapse, another universe might be born. A cycle of fire and rebirth, endless as the phoenix. There is a third possibility, more dramatic still. If dark energy does not remain constant but grows stronger with time, the acceleration will increase. Galaxies will not only flee each other, they will be torn apart. Eventually, clusters would dissolve. Galaxies would shred. Stars would be ripped from orbit. Planets would be cast loose. And then, as the acceleration grew, even atoms themselves would be pulled apart. Space would rip at the seams. The cosmos would end not in silence, not in fire, but in tearing. This is the big rip. But perhaps the strangest fate comes from the theory of inflation. The early universe, in its first moments, expanded faster than light. That inflation ended in our region, giving rise to stars and galaxies. But what if inflation never ends everywhere? What if, while our universe expands, other regions continue to inflate, bubbling off into new universes? In this vision, the cosmos has no single fate. Our universe may freeze or crunch or rip apart, but others will bloom endlessly beyond it. This is the vision of the multiverse. Eternal birth, eternal branching, eternal creation. Whatever the fate, the timescales are staggering. The Earth will circle the Sun for perhaps another 5 billion years, until the Sun swells into a red giant and dies. The stars of the Milky Way will shine for trillions of years. But the fate of the universe itself stretches far beyond even that. Black holes evaporating over 10 to the power of 100 years. Protons perhaps decaying over even longer spans. Numbers so vast they leave language behind. The universe is patient. It ends not in centuries, not in eons, but in eternities. And where are we in this story? We live in a fleeting golden moment. A time when stars still burn, when galaxies still shine, when the sky is still alive with light. We are born in the middle act of the cosmic play, far from the beginning, far from the end. Perhaps one day distant descendants will watch the galaxies fade, and wonder what once was. Or perhaps we will vanish long before, leaving no witness to the universe's final scene. But even if we are gone, the story will go on. The fate of the universe is not only a scientific question. It is a poetic one. The Big Freeze whispers of quiet endings, of embers fading in the dark. The Big Crunch sings of cycles, of death and rebirth. The Big Rip speaks of drama, of cosmic tragedy. And eternal inflation tells of endless creation, a symphony without end. Each possibility is strange. Each is awe-inspiring. Each is humbling. And perhaps, somewhere beyond human reach, the truth waits, written in the stars. So does space end? Perhaps not in walls, but in time. The universe may not stop at an edge, but it may find an ending in destiny. Now we will step away from science for a moment, and listen to the whispers of culture, myth, and imagination. For humanity has always dreamed of the end, and the infinity, of the cosmos. And sometimes, those dreams are as revealing as the science itself. Long before telescopes, long before mathematics, long before even writing, humans looked upward. The night sky was their greatest mystery, their greatest canvas. They saw not physics, not galaxies, not expansion. They saw gods and monsters, fires and oceans, domes and eggs. For as long as we have been human, we have asked, does the sky end? What lies beyond it? And in every culture, answers bloomed in myth, in story, in dream. Tonight, let us wander through those ancient visions and see how humanity first imagined the cosmos. For many cultures, the heavens were a roof, a dome of stone or crystal, stretching over the earth like the shell of a vast egg. The Babylonians spoke of the firmament, hammered into place by gods, separating the waters above from the waters below. The stars were lamps fixed to its surface. The moon and sun were chariots racing across it. The ancient Hebrews told a similar story, a firm dome called the Rakia, holding back the waters of chaos, pierced with windows for the rain. Even the Greeks imagined the sky as a sphere of crystal, within which the stars were embedded like jewels. To live beneath such a dome was comforting. The universe was small, contained, protected. Beyond its walls lay mystery, but the dome itself was a shield. Other traditions saw the universe not as a dome, but as an egg, something alive, something waiting to be born. In Hindu mythology, the Brahmanda, the cosmic egg, floated in the void, containing all of creation. Within it, the universe expanded like a living being, pulsing with life. In ancient Greece, Orphic traditions spoke of a silver egg that split, birthing the sky and the earth. In China, the myth of Pangu tells of the cosmic egg breaking open, its heavier parts sinking to form the earth, its lighter parts rising to form the heavens. The egg was not finite stone, but fertile infinity. It suggested a universe without end, unfolding endlessly like life itself. Many peoples imagine the universe as an island floating on a boundless sea. In Mesopotamia, the goddess Tiamat was the sea of chaos. The gods split her body to form heaven and earth. But the sea remained infinite and surrounding. In Polynesian myth, the ocean was the first thing, stretching forever, from which islands and skies emerged. Even the Norse spoke of Ginnunga Gap, a yawning void between realms, like an endless sea of nothingness, where creation first began. The ocean of myth was not empty. It was alive, dangerous, mysterious. And like the question of infinity, it was both alluring and terrifying. To some cultures, the sky had to be held up. The ancient Chinese spoke of 4 great pillars, mountains that propped up the heavens. When one broke, the sky tilted, causing the stars to shift and rivers to flood. The Norse believed that the world tree Yggdrasil held the cosmos together, its roots deep, its branches high, connecting realms above and below. In many African traditions, the sky was once close to the earth, until humans offended it by striking it with pestles or fires. It retreated upward, leaving us with distance but still supported by unseen forces. The pillars, the tree, the supports, all were ways of answering the same question. If the heavens are heavy, what keeps them from falling? But some stories dared to go farther still. In Hindu cosmology, the universe is vast and cyclical. There are countless worlds, countless kalpas of creation and destruction, stretching beyond measure. Time itself loops in cycles of birth and death, with no true beginning or end. In Buddhism, there are multiple realms stacked upon one another, each higher than the last in an ascent without limit. The Maya envisioned layers of heavens above, each ruled by its gods, and layers of underworlds below. Here the sky is not a dome but a staircase, an infinite ascent. Always higher, always beyond. The Greeks gave us one of the first systematic attempts to bound the cosmos. For Aristotle, the heavens were finite spheres, perfect and eternal. Beyond the outermost sphere lay the prime mover, the divine. The universe was closed, ordered, limited. But for the philosopher Epicurus, space was infinite. He imagined countless worlds, scattered like seeds across the void. No boundary, no end, no center. Even in Greece, the tension between finitude and infinity was alive. One vision sought comfort in limits. The other surrendered to endlessness. The Norse saw an end not in walls but in time. They spoke of Ragnarok, the twilight of the gods, when fire and ice would meet, when the stars would fall, when the world would drown and be remade. Their cosmos was finite not in space but in destiny. A cycle of creation, destruction, rebirth. A story told again and again. In their myth, infinity was not spatial, it was temporal. Endless repetition, endless cycles. Even in myth, some glimpsed a truth closer to ours. As early as the 3rd century BCE, the Greek philosopher Aristarchus proposed that the stars were distant suns, and that the universe stretched far beyond Earth. The idea was largely ignored for centuries, drowned by the comfort of finite spheres. But the seed was planted. Even in imagination, infinity whispered. What do all these myths have in common? They reveal a deep longing. A longing for structure, for meaning, for story. Humans feared the void. They needed edges, pillars, domes, eggs. Or if they embraced infinity, they wrapped it in cycles, in rebirth, in gods. The sky was not just stars. It was a mirror of the human soul. When Copernicus moved Earth from the center, when Galileo revealed countless stars, when Newton united heaven and earth with gravity, these were not only scientific revolutions. They were mythic ones. The universe shifted from dome to infinity, from closed order to endless mystery, from story to science. And yet, the old myths still echo. When we speak of the cosmic egg, we hear the Big Bang. When we imagine the world tree, we glimpse the cosmic web. When we speak of cycles of creation, we dream of bouncing universes. Science has not replaced myth. It has joined it, another language for the same longing. And so, the universe in myth was sometimes finite, sometimes infinite. Sometimes safe, sometimes terrifying. Sometimes bound by domes, sometimes stretched across seas, sometimes looping forever. But always it was alive with meaning. Always it was a reflection of us. We may now speak of expansion, dark energy, cosmic microwave backgrounds, but we are still telling stories. Still painting the night with imagination. For when we ask, does space end? We are not only asking about the stars. We are asking about ourselves, about meaning, about our place in the vastness. We return to science, to the cutting edge of physics. We will explore the quantum, the fabric of space-time, and the possibility that space itself is not fundamental, but woven from something deeper. For the greatest mystery of all may not be whether space ends, but whether space is even real. Imagine floating in space, alone, with nothing but stars above and below. You feel infinite, untethered. But now, imagine that beneath that vast emptiness lies a hidden structure, a web so tiny, so delicate, that it is invisible to all but the most subtle instruments. This is the quantum fabric of space. The idea that what we perceive as smooth, continuous space is actually woven from something deeper, smaller, stranger than anything we can see. Tonight, we will journey into this hidden tapestry, where the familiar rules of reality begin to falter, and the universe itself feels like a dream. The first shock comes from the idea that the vacuum is not empty. In classical physics, empty space was nothing. A void. A blank canvas. But quantum physics tells a different story. Even in a perfect vacuum, particles pop in and out of existence. Fluctuations ripple through space like tiny waves on a pond we cannot see. This is called quantum foam. The universe is alive with jittering energy, even where we perceive nothing. The emptiness of space is paradoxically full. Just as matter is made of atoms, Some theories suggest that space itself is made of discrete units. Imagine zooming in closer and closer. You expect smoothness. But at the smallest scales, the Planck scale, space may be pixelated like a digital screen. Each unit is unimaginably tiny, smaller than a proton, smaller than a nucleus. The fabric of reality may be granular. What feels continuous is a mosaic of fundamental building blocks. One of the greatest mysteries is how gravity fits into this picture. General relativity describes gravity as the curvature of space. Mass tells space how to curve, and curved space tells mass how to move. It works beautifully at large scales, stars, galaxies, clusters. But at the quantum level, space is jittering. Foam bubbles, fluctuations, uncertainty. Gravity struggles to reconcile with quantum mechanics. Physicists speak of a quantum theory of gravity, a framework that unites the smooth curves of Einstein with the jittering foam of quantum reality. String theory, loop quantum gravity, holography, these are attempts to understand the true texture of space. One of the strangest consequences of quantum and relativistic physics is the possibility that space can bend in extraordinary ways. Imagine a shortcut through space, a tunnel connecting distant regions. These are called wormholes. A wormhole could, in theory, make 2 points billions of light years apart suddenly near. Travel through it might be instantaneous, or perhaps impossible. The mathematics allows it. Nature may or may not. The fabric of space is not passive. It can stretch, bend, twist, and possibly connect distant corners in ways our intuition struggles to grasp. And then there is an even stranger idea, the holographic principle. It suggests that the information contained in a volume of space might actually be encoded on its boundary, like a cosmic movie projected from a screen at the edge. In other words, what we perceive as three-dimensional space could be a projection of information written on a two-dimensional surface far, far away. Reality itself could be a hologram. The walls, the emptiness, the vast distance between stars, all of it emergent from a deeper, hidden code. The fabric of space may also be woven with invisible threads. Quantum entanglement links particles in ways that defy distance. Change one here, and its partner elsewhere responds instantly, regardless of the miles between them. Einstein called it spooky action at a distance, but it is real. It suggests that space is not absolute. Connectivity may run deeper than distance, a hidden lattice beneath the cosmic stage. The universe may be far more interconnected than our senses allow us to see. Black holes provide a glimpse of the quantum fabric in extremis. At their core, space is crushed. Time is distorted. The known laws of physics collapse into singularity. Yet quantum theory insists that information is never lost. Somehow, the quantum structure of space preserves it, encoded on the event horizon of the black hole. This is called the holographic nature of black holes. The edge contains the whole. The boundary reflects the interior. It is as if the universe whispers its secrets at the limits of existence. If space is woven from quantum threads, then the universe itself may be a kind of quantum object. It could fluctuate, evolve, and exist in multiple states simultaneously. Perhaps entire regions of space blink in and out of reality at the smallest scales. Perhaps the cosmos itself is a vast quantum superposition, collapsing into the reality we perceive only when observed. The edge of space may not be a wall or horizon, but a veil of uncertainty, where the classical notion of here and there breaks down. This leads to a profound, unsettling truth. The more we probe the universe, the less it feels like a finished stage. Space may not end because it is not a static stage at all. It may be a dynamic tapestry, woven from quantum threads, constantly fluctuating, constantly emerging. Infinity in classical terms, the endless void, may itself be a shadow of something deeper, something that defies distance, defies edge, defies finality. It is remarkable. Humanity's earliest myths spoke of a dome, a cosmic egg, or a boundless ocean. And now we see that space itself may be woven from vibrations, pixels, projections, threads, fluctuations. The universe is stranger than imagination. Yet our intuition, our storytelling, our myths were not wrong. They were glimpses of the same mystery, encoded in story instead of equation. We asked, does space end? Quantum physics replies, space may not even be what you think it is. There may be no end, only a hidden, fluctuating web from which reality emerges. The universe is no longer a simple emptiness or a distant horizon. It is a living, trembling fabric. And at its smallest scales, the cosmos is a mystery without boundary, without finality, without end. We will explore what all this means for our perception of reality, and how the ultimate question of whether space ends might be forever intertwined with the limits of human understanding. Close your eyes and imagine standing at the edge of the universe, or at least at the edge of what you can see. Stars swirl in the distance. Galaxies stretch like islands across the cosmic sea. The void seems endless. And yet, this vastness is not fully yours. It is filtered, translated, limited by the very organ that perceives it, your mind. Your eyes, your brain, your senses, they were never built to grasp the full scale of the cosmos. To understand space, to ask whether it ends, is also to confront the limits of perception. Humans evolved on a planet a mere 12,742 kilometers wide. Our senses evolved to track movement, light, and sound within tens of meters, maybe kilometers. And yet, we peer into distances measured in millions, billions, trillions of light years. We observe stars that burned out long before humans existed, and galaxies that will vanish beyond sight in the far future. The universe is incomprehensibly vast. Our perception is tiny. And yet, our minds find ways to translate that scale, to imagine it, to render it into knowledge, into numbers, into wonder. Our senses are limited. We see only a narrow range of light. We hear only a fraction of sound. We touch only what is nearby. Astronomers have had to invent tools to extend perception. Telescopes to see distant light, radio antennas to detect invisible waves, spectrometers to read the fingerprints of atoms. Even then, every measurement is partial. The universe is not obligated to reveal itself to human eyes. We piece together fragments, clues, shadows of what exists. And in those fragments, the universe teases us with infinity. Because our senses fail, we build bridges with mathematics. Numbers, equations, models, they extend perception beyond biology. Through math, we understand how stars burn, how galaxies move, how space expands. Through symbols and logic, we predict the behavior of black holes, the echo of the Big Bang, the expansion of the cosmos itself. Mathematics gives us a map of the universe. But a map is not the territory. There is always more beyond the equations. There is always uncertainty. Even our minds are bounded. Concepts like infinity, quantum superposition, curved spacetime, they strain the imagination. It is easier to imagine a wall, a dome, a horizon. It is harder to grasp a universe with no edge, or a space that is both finite and unbounded, or a cosmos woven from quantum foam. The human brain evolved for survival, not for comprehending 13.8 billion years of cosmic history. And yet, here we are, thinking about it, questioning it, dreaming it. Every observation we make is mediated by tools, time, and physics. Light takes time to reach us. Signals are altered by gravity and expansion. Every telescope, every sensor, every detector captures only part of the story. We cannot step outside the universe to see it whole. We are trapped inside it, looking from within. This creates a subtle dilemma. The universe may be infinite, or it may be finite. We may never know for certain. The edge of knowledge is the edge of perception. Just as there is a cosmic horizon beyond which light has not reached us, there is a horizon of thought beyond which understanding struggles. Questions like, does space end? Approach this horizon. We can model, theorize, imagine, but certainty recedes as we approach the infinite. The universe becomes a mirror reflecting the limits of our minds. Our curiosity is vast, but the cosmos is vaster. Human intuition is built for a small, stable world. We expect straight lines, local cause and effect, objects with edges. The universe defies these intuitions. Space may curve, stretch, twist, loop. Time may slow, bend, dilate. Matter may exist in multiple states simultaneously. The mind struggles, but it persists. Science extends intuition through reasoning, experimentation, mathematics, and imagination. Yet the edge remains. Some truths may forever lie beyond comprehension. Philosophers have long wrestled with these limits. Immanuel Kant spoke of the noumenon, the thing in itself which we cannot perceive directly. The universe in its entirety may be a noumenon. We glimpse shadows on the walls of knowledge. We theorize, we measure, we model, but the totality remains unknowable. And perhaps this is part of its beauty. Infinity is not only beyond measurement, it is beyond complete understanding. It invites wonder, humility, curiosity. Imagination becomes a tool of exploration. When perception fails, we simulate, visualize, and dream. We picture galaxies, black holes, cosmic webs, quantum threads, multiverses. We tell stories, create myths, craft equations that hint at the hidden fabric of space. All of these are ways of reaching toward the edge. They allow the mind to approach infinity without fear, to wander the cosmos even from a small blue planet. Perhaps the deepest truth is this: when we ask whether space ends, we are also asking about ourselves. Our limits of perception, cognition, and intuition shape our view of reality. The universe may be infinite or finite. Its shape may curve or stretch. Its fabric may quiver with quantum uncertainty. Yet the act of questioning, the act of imagining, is proof of the human mind's capacity to reach beyond itself. The cosmos is both object and mirror, external and internal. We peer outward, but we also peer inward. The edge of space is also the edge of understanding. And so, we return to wonder. The edge may exist, or it may not. Space may stretch endlessly, or it may curve in ways we cannot perceive. Time may flow, loop, or dissolve. We do not need all the answers. The beauty is in the seeking, in the quiet contemplation, in the gentle awareness that the universe is larger, stranger, and more magnificent than we can imagine. And in this awareness we find something soft, comforting, even meditative. A reminder that we belong to something vast, eternal, mysterious. The edge of space, the limits of human perception, they are not threats. They are invitations. Invitations to dream, to imagine, to float along the cosmic ocean, to ponder eternity, to drift in wonder. And as you close your eyes tonight, perhaps you can let the stars carry you gently, like whispers across infinity, toward sleep, toward dreams, toward the endless cosmos beyond sight.